Okay. All right. So good afternoon, everyone. I'm Rob Labossiere. I'm the co-chair of IFMA's Boston Think Tank Committee. Thank you for joining us today for our partner series webinar on NFPA 70B and 70E with EG Sawyer, one of our garden level partners. The mission of IFMA Boston is to provide a full range of programming throughout the year, including publications, training opportunities, webinars, networking, tours, and special events for facilities managers and those who support the built environment in the Boston area. We appreciate you choosing to spend your time with us today. I'd like to now introduce our speakers, Scott Jackson and Mike Joyner, and say a few words about E.G. Sawyer. Edward G. Sawyer Company, Inc. was established in 1864 and is the nation's oldest continuously operating electrical firm. Originally located in Court Square, Boston, which is Government Center. They're currently located in Weymouth now. The company started by maintaining gas streetlights in Boston before transitioning to electrical lighting. Ownership has only changed hands three times in 162 years and is signatory to the IBEW Local 103 and is one of the largest electrical contractors in Boston with three divisions. They have construction, LCN, voice and data, and TEGG service. Fun fact, the original building they were in on the first floor the original building they were in on the first floor, and Alexander Graham Bell was on the third floor. Mike Joyner, just introduce our speakers today. Mike Joyner has been in the electrical industry for 17 years and is a licensed electrician who holds testing certifications in IR, ultrasonic, motors, transformers, cable insulation, ATS, generators, and MV splicing. Mike has been with TGG Service Testing Division at EG Sawyer for 10 years. That's a mouthful. And was lead technician before moving to the sales team. Scott Jackson, also on the line here, is VP at the TEGG Service Division of EG Sawyer, and he's been in the electrical industry for 40 years. His experiences include estimating, project management, sales engineer, regional sales manager, national accounts manager, and vice president, all in contracting, distribution, wire, and cable manufacturing throughout North America, and a partner in a large manufacturer's representative agency. I'd now like to turn it over to Scott and Mike.
Go ahead, Mike, anytime you want to start.
Oh, okay. Hi guys. As you said, my name is Mike Joyner. I've been in the electrical field for 17 years. I've been with EG Sawyer 16 of the 17 years, and then now working for TEG from the field in the office. I appreciate everybody on here today. Thank you for allowing us to come on and speak on our behalf. We're going to be diving into NFPA 70E and 70B requirements. Um, yeah, we can go from there. We'll dive right in. Please be, if you guys, anybody needs to have any questions or anything, don't hesitate to stop me. I have no problem answering questions as I go. And yeah, we'll dive right in. Scott, you are in control of the slides, I believe, right?
I am.
Alrighty. So today we're going to be talking about the NFPA 70B, 70E, and the requirements that now have gone into effect as of 2023. Jump on the next slide. NFPA 70B is a standard for electrical maintenance, and NFPA 70E is the electrical safety in the workplace. And this is going to be talking about how they are used in conjunction with each other to create a safe workplace. One of the biggest changes, as I mentioned, with NFPA 70B and 70E is in 2023 that it is converted from a recommended practice to now an enforceable standard. With that being said, as we go on, we're going to be talking about what that means as an enforceable standard and what is actually covered, what is being enforced when it comes to certain maintenances and certain safety practices that we have to now implement. Scott, want to go to the next one? This is just the quick code book, real quick, just showing you guys what the code books look like. The one on the left is, oh, that's the National Electrical Code. Then we also have the 70E um, code as well, and then with the NFPA 70B at the top. And go to the next one. We are going to start with the NFPA 70E standard for electrical, which is the standard for electrical safety in the workplace, which is the governing body for the arc flash uh, mandating risk assessments, boundary calculations, and proper PPE. It requires labeling with arc flash stipulations for energy analysis, and it categorizes methods to be used to ensure proper work safety. This has been a huge point of emphasis from a lot of our current customers and from these newer customers who've been reaching out. Insurance companies have been one of the big driving force, which I'll get into. And this basically talks about arc flash studies and short circuit coordination studies, all of which is now required. With these arc flash requirements, you are needing to have an arc flash risk assessment. It talks about the likelihood of the occurrence, the proper PPE, as to what people should be wearing as they are approaching live equipment. It talks about potential energized work permits, and it dives in as to what an arc flash short circuit coordination study really is and how and what is required. An arc flash short circuit coordination study is defined by arc flash hazards. Um, It talks about the boundaries, which is the distance of the approach of an actual piece of equipment. And it is categorized through these arc flash ratings, which is measured into calories for incident energy, which we call cal ratings.
Mike,
Most of,
I
yep,
wanted to ask you, I'm assuming everyone on here knows what arc flashing is, but just in case, can you just sort of define that for people? Because there may be some that don't.
yeah, absolutely. So an arc flash itself is basically a incident that could happen within electrical equipment that causes the amount of energy and like a flashover, an electrical surge, and it can get as hot as the degrees up to hotter than the sun. Stuff that will has potential to cause permanent damage, death, and just the incident energy that could happen with an arc flash is it's with an arc flash study with an arc flash itself is basically some sort of a flash that would come over and cause some damage. When doing so, with the temperature getting so hot, um, with the electrical equipment inside, there'll be like shrapnel that has just melted and can blast towards the person, which is why it's very imperative to have an up-to-date arc flash study so we can have know exactly what proper PPE to wear when you're approaching any kind of electrical equipment.
Thank you.
Um, Absolutely. So, with that being said, with the arc flash requirements now, with the short circuit coordination study and the arc flash requirements, what all this stuff means is, or the timeline, I should say, is we would, electrical company would come on site and basically would dissect the building's electrical components, starting from the outdoor pad mount transformers all the way into the switchgear to branch panels, circuit breakers, disconnects, transformers, VFDs. All of this stuff has to be captured, and it all has to be captured and sent to and engineered properly, which they do their calculations to have come up with a proper PPE, or I should say, a cal rating for proper PPE cal rating for each piece of electrical equipment. A lot of building owners now or building operators now have been ahead of the curve a little bit as to what is required for an arc flash study, as labeling has been there, one-line diagrams, and having short circuit coordination studies. But now that it's being implemented, you're seeing a lot more building operations coming out of the woodwork to get this stuff and be compliant for NFPA 78.
Mike, if I
Each,
could.
yep,
Also, one of the reasons why we have the study, especially the coordination study, is because you want to make sure that everything is working in unison and the AIC ratings all match up. And that because you don't want a 20 amp breaker tripping your main in your gear and shutting your building down. And because what happens a lot in buildings, a lot of times, if a breaker needs to be adjusted, somebody will just turn it up to the max, and that doesn't solve any problems. Because if you're having nuisance tripping, that doesn't solve anything. All that does is create more hazard.
hmm
So what the study gives you is everything that needs to be adjusted, fixed, replaced, whatever. Sorry,
coordinated.
Mike. Yep.
Nope, that was perfect. I was about to dive into that because you don't want to have a 20 amp breaker that could shut down a whole entire, not just a panel, it could shut down a whole entire piece of switchgear. It shut down a whole entire nuisance. A nuisance tripping could shut down a whole entire building, which has happened multiple times. So the coordination study is very imperative to make sure that everything is coordinated properly, down to fuses, breaker settings, exactly what Scott was talking about. Each piece of electrical equipment, once the short circuit coordination study is all done from the engineers, there may be certain deficiencies that may be needing to adjusted, as Scott said, whether it's adjusting fuses and adjusting breakers rather than just turning them down. And doing so, we'll be able to go through that with you, but also has it is also delivered with these art flash labels. Labeling is part of the requirements nowadays. Every piece of electrical equipment is required to have an art flash label. Most places do have some sort of labeling, or if they haven't, they do look like this. I don't know if you guys can actually see, but it's sometimes they'll have a generic danger label, but this one will have a warning label, and then it's broken down into uh, the a proper PPE and what to wear. It talks about the arc flash boundary, your hazard, the AIC rating, and it is so imperative for us, for guys like us who are coming onto a site that we potentially have never been to before. And if there is a proper arc flash study done, then we know exactly what to wear. This particular label right here says it's a 6.8. So I know right there, all I need is jacket on, and I'm well within my means of being able to work on certain equipment with, and it tells you exactly what the gloves you have to wear and a face shield, and I'm totally safe. As to certain locations, especially in switchgear, that is when the cal ratings do tend to rise. Our suits are rated up to 40 cals. And they do make cal ratings up to 100 cal suits, I believe 120. Anything above 40 cal is a standard of being a danger. So which is includes switchgear and certain switchboards, all transformers, all of that stuff cannot be worked on live, which is the reason why we do have to wear these suits. And that's why these labels are very imperative to tell us exactly what we're wearing and what kind of proper PPE to wear.
Yeah, and Mike, not to be crass, but 100 cal suit, they call those the open casket suits
Yep.
because when you have a flash, like Mike was saying, it can be 20,000 degrees. It'll liquefy everything that's in there, and the just the impact of the sound waves can do a lot of internal damage on you, and kill you, and damage your organs and kill you that way.
There was a couple instances that I was working in, a couple of buildings in Boston, and they had an Eversource guy, and he was wearing a 40 cal suit. It wasn't properly calculated. The rating for the cal rating was way beyond that. There was a fault. He was wearing his proper PPE, but it wasn't calculated right. And once that fault happened, the flash was so great, it burnt off that suit right off his body. He came out not wearing the suit anymore. And unfortunately, he sort of came to his the the Flash. Um, it is very. I mean, I don't say this to scare anybody, but it's more so to take this severity of having a proper arc flash short circuit coordination study to ensure that you're wearing your proper PPE. I've had some flashes on me, and it is very a nerve-wracking scenario.
There's
And Mike,
Mike. Oh, go ahead, Scott.
yeah, no, I was just going to say, and I know a lot of you out there, you have your facilities, you have facilities electricians, and they have to have their suits as well. If you're providing the suit, then you're covered. If they refuse to wear it, if you have an incident, it's on them
Yeah.
from an insurance perspective. So, and I know that, that's probably, hopefully that's not happening and everybody has their safety protocols in place.
Yeah, I was just going to add, you want to just shed a little bit of light. You're talking about the flash and caloric clothing, 100%, but there's the flash and the actual like blast as well, where even if the clothing protects you from the burning, like it's the impact if there's like CMU walls or doors, you're getting blown out. If you want to just shed a little bit of light on that for the audience.
Yeah, and that's what talks about the boundary. You want to make sure that there is enough boundary for that flash, because if there isn't, you're going to be blown back. I mean, I have had guys who I worked with who have been blown across the wall, hit his head, and he was out of work for 3 years because he had amnesia because he hit his head so hard. It's there is this whole entire NFPA 70E and 70B presentation is going to be talking about safety. That is the number one issue with this, and it's imperative that we have the right up-to-date arc flash and short circuit coordination study to ensure that we're protecting our workers properly for these instances. Because if it there's always that potential. There's always that potential that I have walked into that something could happen. And you want to be as safe as possible. You want to make sure that your boundary is you have enough room just in case if something happens. You want to know and be aware of what kind of hazard you're walking into. With To jump onto that, with these labels, they also have a date in the bottom right on every single one of these labels. With that being said, with the new code update, you have to have the NFPA 7E mandates that the arc flash labels have to be updated. The arc flash short circuit coordination study has to be updated once every 5 years. Now, most buildings in Boston are constantly doing work in it, and the reason why they do it every 5 years is because anything that is added to the building has to be captured and installed onto the switch into the study because the simplest install could greatly affect downstream of the actual study. Again, talking about this 20 amp circuit. If a 20 amp circuit does somehow trip and it's not added and captured by the study, that will trip out anything if it's not properly coordinated. So it is mandatory to be updated once every 5 years. And the way that this whole process works is if you guys have an existing arc flash study and it's just over date, it's beyond the date, then we tend to work with whoever built the actual model. If there are multiple different kind of engineers that are out there, which we tend to work with them. We reach out to them. We do all the data collecting. We go in there, dissect all the electrical equipment, update the actual one lines as much as we can if there is one lines. If there's not, then we will actually draw and create brand new one lines for each of the buildings. And then it gets sent out to the engineer. They do their engineering, and we're able to go through the process with you, label everything, make sure that everything is proper. You guys are all being compliant and making sure that everything is being maintained properly per your arc flash.
Mike, if I could, on
Yes.
when with the engineers, we use Vanderwild for one, we use Pioneer, we use a bunch of different people. And once that die is cast, you kind of have to stay with them.
Yep.
Now, SKM is the software that is most used in our area, and even if we give you the SKM model, and you say, well, I'm going to go to a different engineer, that engineer will not sign off on what another engineer did. So you're starting from the beginning if you do it that way, and it's going to be cost prohibitive. So, most ads are not terribly expensive, but as everybody on here who has had an arc flash knows that when you have it done in your building, they're very expensive.
Yeah.
Yeah. Sorry, Mike. Go ahead.
No, you're good. So the electrical equipment, electrical maintenance, proper maintenance of the overcurrent protection devices is critical to keeping the arc flash and hazard calculated levels. Meaning you have to have, and that's what we're talking about in conjunction with the having NFPA 70E and 70B. You have to have your equipment maintenance properly to ensure the ratings of the arc flash study. If you don't maintain proper maintenance onto your equipment, the arc flash study is not going to be accurate, which is going to lead us into the next slide. Is there any questions about arc flash studies that I want to, anybody? Everyone good? All right, we're good. We're going to jump into electrical maintenance programs, which we call EMPs, or we call electrical preventative maintenance. What these are is also a requirement. It's a document that overall EMP that directs appropriate the safety and operational risks. Um, NFPA 70B tells us how to maintain a proper maintenance program with the guidelines that we're going to be going through and how it coordinates with arc flash. You want to go to the next one? In the 2023 edition of the NFPA 70B, it's shifted from a recommended practice to now a mandatory enforceable standard. With that, there are fines that could be that impose monetary fines as an adopted. It's an adoption means a failure to comply with these maintenance can lead to unwanted penalties from OSHA. Everything being enforced now with this enforceable standard has gone from a should to a shall. OSHA has been known to send citations to people or to buildings if they're not being properly maintained. OSHA, as everyone knows, doesn't show up until something does happen. And when it does, that's when they open up and they do a lot more diving deep into any kind of citations that they can look into. At this point, if a fault was to happen, you guys are now liable, particularly if it's an energized work when you don't have an actual updated uh, EMP or an arc flash, and something does happen. That's when the liability comes in. We are finding out from some of our customers that now they are being audited, and in doing so, when they audit them, they are asking for the up-to-date maintenance plans and arc flash studies. So, with that being said, you need some sort of a documentation, and which is what the EMPs or the EPMs they do. They require you to have your proper documentation for any sort of potential outcomes to happen.
Mike, are you seeing that with like the authority having jurisdiction, whether it be like the city or the different towns and municipalities? It's kind of who's adapting it more aggressively than others.
Yeah, I'm seeing it more in Boston more than any places. I mean, bigger towns,
Yep.
bigger like that.
Yep.
Not so much in the outskirts. I am seeing in inspectors. Inspectors now are
Mm,
noticing this stuff, especially with the arc flash labels. When they're on site to take a look at something, that's one of the first things that they have been known to look for now. And then in doing so, they're not pushing it just yet, but they'll give you guys a heads up. Be like, hey, just letting you know, your arc flash labels are out of date. And then
yes.
in doing so, sometimes it goes into a different kind of conversation as, well, do you guys have a maintenance plan? Do you guys have thing? And then it's more like a knowledgeable kind of thing.
Hmm.
Now that, I mean, it is still fairly new, that everything is being implemented the way that it is and enforced that it is. So we are starting to hear more and more people with the audits, more so from insurance companies
Hmm.
and starting from inspectors, fire marshals. Fire marshals are another one too. When they're on site, they're doing pump tests or whatnot. That's one of the things that they'll also look for.
Awesome. No, I appreciate that. And I mean, for everyone on this call, and that's why we have like partners like yourselves. And obviously, we have a long-standing relationship with Liberty as well.
Yep.
We leverage, because you guys do service for us. Um, However, you guys are doing service everywhere. So sometimes you have your finger on the pulse where you're like, hey, City of Boston, the last 8 sites we've been to are requesting this. You know what I
Yep.
mean? And that helps us or facility managers, property managers to know like, uh-oh, they're going to ask, they're going to crack down. And we've seen it time and time again, even with like say project when the general contractor asks for it, and it's like, huh, I've been here for 15 years. I've never had that asked. Then you do the next project, different general contractor, ask the same questions. So I think that's, yeah, it's good insights and appreciate that. And when the time comes where you're seeing more and more of that, that'll be huge for us or everyone if my boss and facility managers get dialed in. Because it's not if, it's when.
No,
And
absolutely. Yeah.
where a lot of the confusion is, especially what we see with facilities folks, um, they'll know they know they have to have a maintenance program, and well, how do I go about it? And the biggest confusion, I'm just going to jump ahead here, Mike, just for a sec, uh, is how NFPA 70B defines conditions and conditions of equipment. That makes your head spin. It's but we clear it up. We're kind of the experts who come in and help define that. And what we're starting to do now is we're starting to help you folks write your programs.
Mhm.
Nice.
So that way, it's a simple piece of paper that so you can hand it to OSHA, insurance, whomever, and say, this is what we have in process. Because what they want to see is that you're doing your infrared testing every year. They want to see that you're doing your shutdowns every 3 years or whatever,
Mhm.
five
Yep.
years. They want to know that you have a plan. That's the most important thing. And
Mhm.
you can't deviate from the plan, because if you do, and you say, well, I'm not going to do that shutdown this year, and something happens and OSHA finds out, they make you do the shutdown 3 years in a row as a
Oh.
penalty, because that's the most expensive part of the whole thing.
Yep.
Mhm.
So anyway,
Yeah.
sorry, Mike. I know I'm jumping
Yeah,
ahead like
they're mandating these de-energized maintenances, these energized and de-energized maintenance, and it is tough, and I know it's tough because there's always a will and a way to actually shut things down. We have shut down hospitals, we have shut down data centers, we have shut down certain labs. I mean, we're able to bring in generators to kind of backfeed certain things, depending on what kind of equipment it is. There's always a will and a way, and it's just now it's everything is now a requirement in order to do so. Uh, Talking about fines, Scott, you want to go to the next one?
sure.
For with it being shifted from a recommended to now an enforceable offense, OSHA will come in and they will penalize you after the first offense if you do not do your energized, de-energized maintenance, if you don't have an active arc flash, if there is some sort of an incident on site, the one of the first violations is a serious offense is up to $16,000, and that's just up that's per violation. If you're a willful repeater, then they'll come back on site and they will follow up with you. And per violation, it could be up to 160,000. With that being said, I mean, you're looking at, potential forcible shutdowns. They can come in, like you said, and force you guys to have an actual shutdown. If you didn't do it this year or you haven't done it in 5, 10, 15, 20 years, you missed all these different cycles, they're going to force you to come in and they're going to shut you down. But on top of that, though, the main reason why we're doing these shutdowns is for your equipment. Your equipment needs to be maintained. You don't want to have any kind of unplanned downtime that you have potentially. You don't want to have any kind of fault down line that could actually somehow increase some sort of an arc flash or some sort of a fault. And shut down your actual switchgear when it's not planned. You'd rather be proactive than reactive. And OSHA just is now implementing it so it can kind of, force your hand in order to do so. One of the reasons, I'm sorry, the reasons for the fine is you have to maintain your proper documentation for each of your EMPs or EPMs. With us, we have documentation going back from the early 2000s. Actually, TEG itself, I mean, I don't know if we mentioned this, but is one of the first TEG franchisees, yeah,
Mhm.
that's a word.
We're,
Franchisees.
yeah, we're one of the originals. It was over
We're
30
one of the
years.
originals. We've been doing it for 30 plus years. A lot of our guys have been doing it for 10 plus years, and they have the records and the knowledge of know what they're doing when they come on site. They're able to find the knowledge. I'm sorry, the records. Where if we go onto a site, you guys newly taken over the building, we may have the records of that. That way, if you have your insurance company or OSHA or whatever it is asking for records, but we may potentially have some sort of record for you. With that being said, one of the reasons for the penalties, obviously, as we're talking about, is the art flash and failure to testing and proper maintenance for all of your equipment, your electrical equipment that you have on site, whether it's breakers and transformers, trip settings, trip units for these breakers. A lot of that stuff can lead to unwanted downtime about being, again, you want to be proactive rather than reactive. So in doing so, it is very imperative to stay on top of maintenance plans. Scott, you want to go to the next one? When going with these maintenance plans, it talks about potential intervals. One of the biggest articles that I have memorized now is from NFPA 70B, table 9.2.2. It clearly defines as to what pieces of equipment has to be scanned, has what kind of scope of work has to be done towards these equipment, whether it's infrared scanning, energized maintenance, de-energized maintenance, visual inspection, any kind of cleaning, tightening up, testing. There are this table clearly defines everything, and it breaks it down into three conditions, as Scott was talking about. It talks about the frequency of how you're going to be shutting the buildings down or energized testing that we have. It talks about what is mandatory and what kind of equipment is actually covered. Um, One of the top lines when I go into the next page or the next two pages is we're going to be talking about infrared scanning. Infrared scanning, before the way that the practices that we used to do. We used to do 1 year of infrared scanning, which involves visual inspection and looking for code violations. The next year, we always did a de-energized maintenance, and then the following year would be another infrared scan. And what would happen is we would scan the building, find any problems, fix the problems during the de-energized maintenance, and then the following year, ensure that the problems are there. Because of this new code and this new table right here, it tells you that everything has to be infrared scanned once a year, every 12 months. And it breaks it down into condition and tells us frequency as to what other practices have to be done. Scott, you want to go to the next one? And talking about the condition of the maintenance. Now, what exactly does that mean? Well, this 70B actually breaks down into what kind of conditions they are and further explains it as a certain standard as maintenance cycles. You can actually go to the next one with this one. So this one was a further explanation as to these conditions that we're talking about. This one right here was going to be talking about condition one. Condition one is like brand new equipment. It's a brand new building within 5 years or so, and you're walking in, there are no problems that we're seeing. Anything is like new. There's no moisture. Everything's clean. There's no corrosion. And everything ever since the building has been up, you guys have been maintained, which is a perfect condition. You can go to the
Hey,
next one.
Mike, now
Yep.
hang on for a second. Well, just so that everybody knows, you build this nice new building and you think, well, why do I have to maintenance it in the first year? Well, throughout the building construction process, all that drywall dust ends up in the switchgear. As an example, there is one customer that we have. They were building a building which is basically connected to their existing building. And in one of the rooms that was exposed were the gear and the UPS. And an electrician opened the door of the UPS and it had an arc flash and it put him through a wall. And when you looked at the filter, it was caked with drywall dust. So just because it's new doesn't mean it doesn't need to be maintenance. Yeah, Mike, sorry.
Yeah, absolutely. Which is absolutely fair. So you can go to the next one. So this is condition one, like he's talking about condition, like new conditions. Condition two is pretty much almost every other building that we've seen for the most part in Boston. It has some sort of a maintenance program. Has been shut down, de-energized maintenance before. You have some awareness of what kind of problems you may have, and you're actively trying to keep up to par. Now, in doing so, this when we go into the actual chart, it'll tell you exactly the frequencies and everything. But this is pretty much every single building that I have really kind of walked into. It's very rare to see anything beyond this. Condition three, I have seen a handful of times, but condition three is you're walking into a mess. Everything is very scary. You're looking at caked on dust. You're looking at like you're walking in, and immediately you just uh, see the cockroaches and mice and this and that and everything that it's a mess inside there. That most buildings are not like that. Most buildings are pretty well maintained, but they are like that. That I've seen that would be condition three. In doing so, it means you missed the multiple cycles of the EPM or any kind of DE, which going back to what we were talking about before, if it's enforceable from OSHA to have multiple de-energized maintenances to come back up to par to get yourself into condition two. You want to go into the next one? You want to show them the table?
Sure. But before we go there, a question is, all right, if I'm in condition one, why do I get put into condition two if it's all new and it's in good shape and all of that? If after and who determines this? Well, we determine it because we're expert in the field and we see what the conditions are. But what happens is if you're in condition one and we do all of our studies and all of our testing and whatnot, and we find issues, that automatically puts you into condition two. So just to clear that up.
And Scott, condition two is acceptable, right? It's you're
Oh,
working with it.
absolutely.
You've got your
Yes.
plans. They don't
Yeah,
need to. Okay. It's really
yeah,
condition
no,
three where you get more, but obviously even more concerned.
yeah,
Correct.
no. Condition two is fine, and like Mike said, I would say 98% of all the buildings we're in are condition two.
Condition two.
Yeah,
Yep. Yeah, it's very rare to see a condition three. It has happened. And then same thing with condition one. Like we do see it. It's more so new buildings. But within the first 5 years, I mean, it does go into condition two. As you can see in
we,
here,
we do have a customer in condition who's constantly in condition one. They're a member of IFMA. Their buildings are so well maintained that they live in condition one. Go ahead. Sorry.
so this is the table of 9.2.2. We only included the first page uh, of the table because it goes on to 13, 14 pages. It actually takes up most of the NFPA 70B. If you guys do look on the top line, it does say all equipment infrared thermography. It doesn't matter between condition one or two. It does mandate that it has infrared scanning has to be done once every 12 months. Condition three, if you are in that condition, it has to be scanned twice a year. That is to bringing you back up to par and to get to condition two. With all of this, it is broken down on the left-hand side as to what sort of equipment that it is, whether it's busway, cable tray, and then it goes down to switchboards and branch panels, disconnects. The scope of work defines on what needs to be done, whether it's infrared thermography, visual, cleaning, lubrication, mechanical, electrical testing, and then manufacturer testing as well. Manufacturer spec testing as well is all throughout the scope. And then through condition two, one, two, or three, like I said, it dictates the intervals. Condition one right now, especially with the what they're talking about when it comes to cleaning and lubricating mechanical things, that is the de-energized maintenance we keep talking about. That is the time when we would be in there to shut things down and exercise the equipment, lubricate things again, and do our special testing per each manufacturer equipment. Condition two is you're looking at condition one would be once every 5 years. Condition two is once every 3 years. They recommend doing the de-energized maintenance. And then obviously condition three, it says on the far right that you're looking to do a de-energized maintenance, a cleaning for it once a year until you get back up to par into condition two. Uh, all set with this one? Based off of 9.2.2, uh, when we do these shutdowns, there are other tables that tell us exactly how to properly maintain the conditions of the maintenance of the equipment. In here, there's multi-case breakers, insulated circuit breakers, low voltage breakers, as well as the medium voltage breakers. The following table that we're going to dive into, it basically talks about how and what frequency we have to work on these pieces of equipment. Just because all of these breakers are in the main electric rooms or whatnot, they, as Scott said, I mean, the amount of dust and everything that is accumulated throughout the years can greatly impact these breakers. It's why it's imperative to really do these shutdowns. I have gone into a building before where it has never been touched. We opened it up, and the dust itself has been electrically charged. We killed everything. In between each of the bus, there's about 3 to 4 inches, depending on what bus we're working on. I have a picture somewhere of dust actually being vertically electrically charged about halfway up to the next bus. And if it did make contact, you're looking at a phase-to-phase short, which could cause a catastrophic incident within your switchgear. Um, so that is something that it's very imperative to go inside and make sure that these switch gears, these multi-case breakers, everything inside there is cleaned out, tested properly, and re-lubricated. If these multi-case breakers, these insulator breakers, are not properly lubricated, the lubrication inside there acts like a glue, which we're going to get into in the next couple of slides. So, Scott, you want to go to the next one?
Sure. And just remember, everyone, we're talking about electrical components, but just because they're electrical components, they're also mechanical components.
Yeah.
We have switches that ratchet, and if you don't physically work them every so often, like Mike said, they freeze up. And the big problem there is when you do go to do it, you can't get the breaker to work again. And Mike's going to talk about that.
So this is some of the visual inspections, the guidelines that we have to go through while we're actually in the switchgear. We are looking at some of the wiring, the cabling, sometimes and throughout the time with the heat and stuff, it can crack. We look for anything that is kind of broken leads. We make sure that all the connections are properly tightened. Look at any kind of visual components. If there are any chutes or cracks, we inspect all the chutes and see for any cracks, any kind of tracking, any kind of corrosion. That absolutely does tend to happen over time. Electricity is creating heat, and in doing so, it can greatly impact these breakers, the cables within the actual components of the switchgear itself. So while we're in there, this kind of gives us a guideline for a certain visual inspections that need to be done. Scotty, go to the next one. And then this gets into the cleaning for the de-energized maintenance we were talking about. You know, we go in there, we start from the outside in. We have shut down buildings. Like I said, there's a will, there's a way. We've shut down numerous different types of buildings and occupied buildings that we start from the outside in. We clean the outside. We make sure that it is actually bolted down to the ground. We check for any kind of violations once everything's all opened that you normally can't typically do during the regular infrared scanning or maintenance site visit. We clean and test all the breakers. We clean and test all of the bus and the gear. We exercise all these breakers that are in there. All the clean out all the grease, all the moisture that is found. We clean and we sometimes I guess what happens is the incoming from outside. We the in the I'm sorry, the conduits coming from the outside pad mount. Back in the day, they used to leave them exposed or open or not stuffed, so we put insulation in there. There are many potentials of having, like I said, mice and rodents, and we did a shutdown, or we had to go to respond to a call, and there was a possum who had actually made its way through the conduits into the switchgear and bit down into the live wires. I mean, they're trying to do it for heat, and they bit down the live wires, and it caused an extreme blast. Got to the point where we went there and actually opened it all up. We weren't sure exactly what it is. We were trying to figure out exactly whether if it was a possum, a raccoon, a squirrel, a chipmunk, and because all there was just a skull. That was skull was just left over. So it's very important to make sure that the cleaning inside there and the proper care for the gear is taken serious. And in doing so, it's you know clogging up for insulation inside this gear, not just for the rodents, but just for for future if people were uh, trying to run new conduits or run new wires in there and they don't want to send like a snake down or something. Like it's just so we go inside there and make sure that everything is clean, working off properly, closing up any kind of holes or any kind of potentials that they might have in there, and then relubricating thing because if there was any kind of fault downstream, and God forbid if there was a fault and these breakers aren't opening, which they should, or trip the way they should, because it's not properly exercised or greased, that can seize the breaker shut and just continue this arc and arc and arc. So it is very imperative to make sure that everything is taken in maintenance properly. You want to go to the next one? So this jumps in real quick as to what kind of testing is done while we're on site for the de-energized maintenance. With the primary and secondary injection testing. We do measuring and ductoring and ensure that all the breakers are working properly and exercising. Per manufacturer spec, sometimes they talk about primary, secondary injection testing, which is what this table is included. When I was in the field, primary injection testing, which for lack of better terms, was in my mind as always a destructive test, especially for older equipment. Newer equipment actually does require it for like newer Eaton equipment or Siemens equipment, and that is once every 5 years. But for the most part, what you're doing is you're putting 300% of continuous load into the actual breaker itself. And if the breaker's not rated for it, or if it does kind of cause any kind of faults, if you don't have a backup breaker, the breaker's going to fail and you may be out of luck. So we actually tend to stay away from primary injection testing unless it's manufactured spec for the newer equipment. You normally mostly see that for acceptance tests before this stuff was installed and sent off to your locations. The secondary injection testing is testing all of the instantaneous trip, the trip settings, the relays, everything that's internally for the CTs of the actual breaker itself. And then we can jump
I,
on to the next one. Is there any questions on
yeah,
this one?
just a quick one on primary. Um, and Mike's right. It is a very severe test. And remember, those breakers only have so many actuations that they're designed for. The problem being more so in the switches, the bigger switches. You have a 4,000 amp switch, that's a $30,000 breaker. And trying to find it, it may be a couple of months out. So unless you have one sitting on the shelf, be careful. That's all.
This is just quick photos of some of the guys doing some cleaning. These are high pressured uh, breakers that you'll be able to see. He is cleaning off the left-hand side is him cleaning off the grease inside the fingers. And we're re-greasing them. That's a secondary injection testing. Middle, and then doing that testing. So, the next one. So the areas of emphasis, and this is more so about our TEG software and how we capture our equipment or our data and document everything for you guys for the Arc Flash and for the EPMs. Our software, what we do is when we come on site is along with the infrared scanning, we capture as much information as we can per each equipment. Everything is categorized. So we'll be coming in, say if it's a branch panel, we go into the branch panel, we put our EG soil labels on there and identification numbers. Most of you have seen them somewhere throughout your buildings. And in doing so, it's everything is installed into the software as to the location, the manufacturer of the panel itself, whether it's a main breaker or a main lug only breaker, whether it's a 42 breaker panel, say it has only 30 breakers in there, those 30 breakers, they'd be identified as what they're serving, say if it's a lighting or motors or annually units, everything is well documented as to what that panel is doing. It captures the voltage, the amperage, and voltage and amperage and any kind of problems that we may find whenever it comes to infrared scanning and if it comes to a code violation. All that stuff is documented into our TEG software, where at the end you get a report, but you'd also have access to an online portal where you'd be able to see everything at your fingertips as well.
Hey, Mike, we have a question for you.
Yes.
From Tim Thanakos. What type of buildings do these regulations pertain to? I work with a bank. We have 40 to 50 different sites ranging from multi-story office buildings with data center and generator backup to small branch with electrical room with one or two breaker panels.
Mhm. All of them. Though those are exactly it's in the code now that all of these buildings are all kind of occupied buildings, regardless of if it's a small bank, whether if it's a high rise, it is now a requirement that all these buildings are have to do some sort of a maintenance plan. With a lot of it is for IR scanning, de-energized maintenance for arc flash purposes. Nobody's really out there enforcing things until something actually happens. So just because OSHA's not there at the door right now saying, "Hey, you have to have your infrared scanning and you have to have maintenance on this stuff," it's not being enforced, and they're not gonna force it until something happens. Um, which, again, same things where, a lot of these buildings have been up and running for 15 years and haven't been maintained. That's great. And if you want to keep it that way, that's great. But if something happens, and at that time, let's say it is 15 years, something will happen. At that time, OSHA or inspector or something like that will come on site and they will mandate you to actually perform these maintenance plans. Does that
Just,
answer that?
oh, sorry. Tim, did that answer your question? I think he was typing. I was just going to say, like in a perfect world, how it really goes, like the infrared or the thermal imaging scanning. It's really just going to the panels. I don't mean to simplify it, but they have qualified guys from TEG. They have the camera, as you mentioned, gives you the reports, kind of gives you See it. Yes, thank you.
I
right,
actually
so
expect a response like that. Like
yeah,
there are a lot.
I know.
I'm starting to do these little lunch and learns more and more.
Yes.
Uh, and in
Uh,
doing so, that has been people's response, like, "Oh God, now I have to do this." And like, I understand, and I'm not trying to force this down your throat. I'm just trying to explain to you
Educate.
guys what the
Hmm.
new requirements are as an electrician's point of view. I'm an electrician. I'm newly into project managing and sales, and I'm just
Hmm.
trying to explain it on my end as to what we have been seeing out in the field, as to how the requirements are pushed.
Yes.
and,
No, that's
and,
fair enough. And
and
go
by the
ahead.
way, so we do banks already.
Yeah, we do. We do.
And what I was going to say is like Rome wasn't built in a day either. So like it's easy to get overwhelmed when you say 40, 50 buildings. It's
Yep.
kind of almost like prioritize. And what happens over time, you do the thermal imaging, infrared, you may find some anomalies, some may be easy fixes, some may be hotspots. But then as you plan ahead and you start to do shutdowns, you could say, oh, hey, there's these 7 deficiencies. We're shutting down anyways. So now it's kind of planning the work the plan. And typically, once it gets brought up to snuff, after that, it's just kind of routine maintenance. You
Yeah.
kind of iron out all the wrinkles. But yeah, I mean, that's the only advice I would say is don't get overwhelmed. I feel like in everything we do here, the day in the life of facilities, there's some other new regulation or jurisdiction or something that we have to do. So,
Andrew, based off of what you just said too, like what we
yep.
used to do and the way that I was like the way that when I got into this, the way that it was they would do 3-year contracts. We always did 3-year contracts. The first year would always be like an EPM, an IR scan, this and any problems that we'd find, we'd present it to you guys. The second year would be a de-energized maintenance, no infrared scanning. And during that de-energized maintenance, we would take care of all the problems, anything that we found for the first one, because that's the prime time to do it. And then the third year would be another infrared scan
Mhm.
and ensure that all the problems that we fixed is still up to par and working properly. Because of the
Yes.
new code and that table 9.2.2, that top line says all electrical equipment has to be infrared scanned every 12 months. So in
Mhm.
doing so, we now do 3-year contracts, all infrared scanning, but we do offer another de-energized maintenance separate contract as well.
Mhm.
With that being said, we still incorporate the same scenario, whereas any problems that we may find, let's try to take care of it during the de-energized maintenance and then go from there. Once you guys start on a plan and a maintenance plan, that's where you're going to find a lot of the problems are going to be going away. We're going to be taking care of things, and your buildings is going to be up to par and compliant with any kind of maintenance issues that you guys may have.
Mhm.
Um, so it's just it is a process, and the thing is, this originally got implemented in 23 when it got switched from a recommended practice to a standard now. So, but it wasn't really enforced until 24, 25. And now being in 26 and going on every 3 years is a new code book. So, this year, now everything is more implemented. We're seeing, actually, Scott, you want to go to the next page?
There's not going to just real quick, not to lose your thought, just tell you to jump to 1 o'clock. Two
Yep, of
things. One, this is excellent. Thank you so much. Sorry, I have to jump short. And
course.
probably for Tim or others, the biggest thing is it's always the impact. At the end of the day, it's always the impact. We're the silent
Yep.
army, like everything's behind the scenes. So usually it's the budget. It comes down to budget to try to stay relatively flat, but get a 3-year contract. You can get it into the budget. And then it's kind of the impact. It's really like, so if it's a bank, it's like, okay, we won't do it. You can do all the fit outs. And I say, like you put lipstick on a pig. However, the behind the scenes with the electrical components, you could say, what's the impact for the bank? Okay, it's the online banking, it's down, or whatever the impact is, because now you're speaking their language. Where let's just say it's 10,000. I don't know what it is. What's the impact of when they lose the online banking now on the business? And that's the conversation. I know every business or every every company's different, but that's usually when you're trying to talk to the C-suites or the leadership team. Just say, I just need you to understand the impact and like not doing this and what could it
Yeah.
cause. So that's all.
And going back into being proactive rather than reactive. We're trying
Yes.
to do it so to minimize any kind of potential downtimes.
Awesome. Thank you all. Appreciate it. Take care.
And I
Thanks,
just
Andrew.
want to, before everyone else starts to jump too, I want to say we're are we able to send out these slides as a PDF from you guys along with your contact information so that everybody knows they will get them?
Yeah,
Sure.
absolutely.
Yep.
And please,
Perfect.
reach out. I mean, I have no problem walking to each building and coming up with some kind of quote and get you guys onto a maintenance plan. It'll be something where we understand it's a process. We understand budgeting reasons. Again, with it being starting in 23, nothing's really implemented until as of like last year, this year, and we're starting to see more and more people come out of the woodwork because of this.
Yep.
And we totally understand that it's a budgeting issue. So with this being said, I legit have one more slide left after this, and I am all done with you guys. If just in case, and I'll be happy to answer more questions afterwards. But
That's great. Thank you.
getting into this infrared thermography, what that has to, and what we do while we're on site, we can go right here. Um, this is what we're capturing. We're capturing kind of hotspots, and while we're in there doing the infrared scanning, we're looking for code violations, but certain things like this. And that's why it's very, you want to make sure that you have the right people, the qualified people, licensed electricians, infrared level one, level two, level three thermographers, because we're now having people come out of the woodwork who, a particular person up in Maine who came down, and I was bidding up against him on a job where he portrayed himself as an infrared thermographer, and he wasn't a licensed electrician. And if you go on his page, he strictly did energy loss from Windows. He has IR scans of Windows and energy loss where he's like, oh, I can do electrical now. It doesn't work that way. When it comes to electrical infrared thermography, you got to make sure that you open up all the electrical equipment, expose yourself. You have to take the dead fronts off. You have to be able to see inside. Like a perfect example on the one on the right, that could be a cross-threaded screw, a loose connection right there. You wouldn't be able to see if the dead front was on. Infrared scanning, infrared thermography does not read through metal. So it's very important to make sure you have the right qualified people to go in there to take off everything, to expose it properly. The one on the left, it looks like a similar breaker, but that's hot in between the contact. We'd be able to figure out exactly and diagnose as to what the issue is, not just being hot. We'd put our meters on and actually dictate that, hey, you'd have to replace this breaker. This breaker is actually failing. So it's definitely does take somebody who is qualified, who has the knowledge and background as to what they're looking at as an infrared thermographer.
And this all goes into our software. The technicians put it in. They put in their diagnosis and the repair, and that's all
Recommendations right there.
in a portal that you can go into and have access to everything.
Yep.
Yeah, and just to follow up on what Mike said, if somebody's telling you they can shoot through a dead front, or a cover, say thanks anyway and move on because you can't.
It's reflective. You can hold up the camera and you can actually see yourself going like this. And if you're in front of the actual equipment, your heat is reflecting off of it, so you don't even know if it's an actual problem or not. They can capture and say it is, but then if they take a side camera, side picture, it's totally different. So it is something where you have to have somebody who is qualified and trained to do this. So, and that's
There it
it.
is.
So I told you one more slide left, and yeah, that's me. Are there any other questions? I mean, I try to hope that I was able to answer certain questions as much as I can.
Any questions? I know that was a lot. There's a lot of
Yes.
information.
A lot of information. I don't mean to overwhelm anybody.
No, it's perfect. We need to get that out there, and we can always do follow-ups, and people can reach out to you individually as well. So
Yeah,
Absolutely.
we can come out and talk to you groups, whatever you need.
Lovely.
Perfect. All right. Well, Scott and Mike, thank you so much for walking us through this today. Thank you everybody for joining. If you're not a member of IFMA Boston, we hope you found today's program valuable and that you'll consider joining our chapter. You can find more information on our website at ifmaboston.org or reach out to geo@ifmaboston.org. And don't forget, our next event is the Spring Golf Classic on June 16th at Red Tail in Devons. Foursomes are sold out, but networking tickets are available for the end of the day. And if you need anything else, you can always reach out to Gio, myself. I think Andrew jumped and Rob, but again, Mike, Scott, thank you guys so much, and thank you everybody for joining. Have a great day.
Thank you guys for having us.
Thank you.
Thank you.
Have a great day.
You too.